All right, first thing we always have to find is other angle C. How do we find out what angle C is? Yeah, 180 minus the other angles. Whatever's left over, that's what C has to be. So if you do that, boom, you get 61.5 degrees. Okay, now that we know angle C, we can use the law of sines because we have a pair of a given angle and a given side to find our missing side B. So we can say B over the sine of B is equal to C over the sine of C. Plug in, we get B over the sine of 22.5 degrees is equal to 30 over the sine 61.5 degrees. And I've got one more step to solve this for B. What do we do? Yeah?
Multiply the sine of 22.5.
Yeah, we want B by itself, so we need to get rid of this dividing by sine. And the opposite of dividing by sine is to multiply. So we get B is equal to sine 22.5 degrees times 30 over the sine of 61.5 degrees. Type that into the old calculator, and we find that this tree is pretty tall. Let me tell you what. That's 13.064 meters. Which would be about 42.5 feet tall. So that tree is just a little bit taller than I am. Right? Yeah. Question about number one? The key is whenever you're given two angles and a side, always find the other angle first. And then use the law of sines to find whatever missing sides you might need. All right, number two here. For what two values of x is the equation x squared minus 5x plus 6 equal to 0? True. There are a lot of different ways I could solve this problem. I could factor, quadratic formula, graph it in my TI-84 and find its x-intercepts. Or, because they give me the answers, I could plug in and see until I find which one works. Which do you think would be the fastest way to do it, though? Factor. If that is not your answer, that is okay. But I will tell you, for me, factoring is really quick. If I want to factor this, what are two numbers that multiply to be positive 6, but add to be negative 5? Negative 2 and negative 3, which means x is 3 and 2. Boom. That's pretty quick. If you had the quadratic formula, I think it'll take more time to write x equals negative 5 plus or minus the square root of negative 5 squared minus 4 times 1 times 6 all over 2 times 1. Unless maybe you had Mr. Rupp for physics and he programmed into your calculator the quadratic formula, then maybe it could be faster. I don't know if you're actually allowed to do that though. Supposedly, I think they're supposed to clear your programming before they take the test, but I don't think they actually ever do that. Like they don't go around and grab everyone's calculator and clear their programming. So this one's not too bad to factor. I just factored it. So hopefully that's a question you could get done in 15 to 30 seconds to save yourself more time for those later ones. Questions about the bell work? Alrighty then, we get to do the lost sides today. Finish that out. This will be exciting. So we did this already, 2 angles and a side. Today, we're going to do the ambiguous case, 2 sides and an angle. So if you had me or Miss Waters for geometry, I'm sure you have heard this before, but there are only 5 ways to ensure that a triangle is congruent to another. There are only 5 ways to ensure that this is a set triangle, and that is they can be side, 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 angle, side, or angle, angle, side, or hypotenuse, leg, right? And side, side, angle, or ASS, didn't work because it could create 2 different triangles depending on how you made the 2 sides and an angle. So if we have to do an oblique triangle with 2 sides or an angle, there are a whole bunch of different cases that we could run into. You do not need all of this in your notes. What you do need in your notes is the following: this title and this. This is for when A is acute. And these 2 cases are for when A is obtuse. And I'll be honest, the only reason why you really need this in your notes is for one homework question that will not be on the quiz or test. But how this works is, depending on the 2 sides and an angle you're given, you could have no triangle. You could have that there's only one possible triangle, or you could have that there's 2 possible triangles. In the first case, if the 2 sides and the angle they give you, if that side A is so small that it cannot reach the base because it is less than the height of your triangle, then that triangle cannot exist. So if A is less than the height of your triangle and angle A is acute, then your triangle cannot exist. If A is the same length as H, then this is actually a right triangle. And you get one possible because this is now hypotenuse leg, right? You know the hypotenuse, you know a leg, so there's exactly one solution. If A is greater than B, then there's only one way that you can make it work, and you'll have one solution as well. The issue comes if A is between H and B. If A is between H and B, then there are 2 ways I could connect A to the base, which means there's 2 triangles that I could make that have those measurements for my side, and angle. If A is obtuse, there's only 2 cases. Either A is too short that you can't make a triangle at all, or if A is greater than B, there's only one type of triangle it can make. So again, there's one homework question that asks you about like those possibilities, but ultimately when you actually go to solve problems, you won't use this at all. This won't be helpful to you at all for most of the cases that you'll do. And theoretically, I suppose I could ask you about this type of problem on the ACT, but I've never seen them do it, so you're probably fine. All right, anybody need more time to write? A little bit? I labeled my cup this morning. I went to that Starbucks fill-in, lake instead of lake with a B, Blake. Now I have to go on Yelp leave a bad review, and do all this extra paperwork. Almost asked to see a manager over that one. Thinking my name's Blake. Do I look like a Blake? Do I have a skateboard? Wearing my hat backwards? That's all what all Blakes do. They have skateboards with them all the time and wear their hat backwards. I think they're so cool. I suppose. Has it started to warm up outside at all? What's the temperature? 54. It looks warmer than 54 degrees outside. My furnace at home stopped working last week. So I don't have it central heating anymore. But I'm like, it's almost summer. So is it worth it to pay somebody to go out and fix it now for the 1 week? So I think we just decided to do space heaters. And we're just going to convert the gas furnace to an electric furnace because we're going to get solar panels installed. So it seemed like a good idea. Rather than fix it, just replace it. Which has turned out to be a pretty big headache because the guy that we're going to have replace it gave us a quote, but then they called the person and they were like, oh, our furnaces aren't solar ready. And I asked him, what does that mean? And he goes, I don't know. I don't know what that means. Well, I don't want you to hook it up to solar panels. I want you to hook it up to the grid, to the breaker box. So it doesn't need to be solar ready. I don't want it to just run off the solar panels because what if it's snowing and they're covered, whatever. It seems like a really bad idea. And he goes, I don't know. I go, well, I think I dodged a bullet with this company. But now that's more work on my end. Yay? All right, I'm excited. Look at what's about to happen. There's a glorious little problem right here. Look at this one. For the triangle below, find angle BC and side C. Notice that for this problem, we are given two sides and a non-included angle. We're not given the angle between them. So this is the ambiguous case. Ba, ba, ba. To solve the ambiguous case, ba, 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 what you're going to do is we can't start by solving for our angles, right? B and C are both missing. So I can't do the little trick where they add up to 180. So instead, we start with the law of sines because I am given a pair. So I'm going to do, okay, and I'm going to do this. I'm going to use the alternative formula that's in your trig cheat sheet. Oh, George. Use the trig cheat sheet. It's got everything. Yeah. Everything from this semester. Unit circle, all the formulas, all the identities, law of sines is the last page. And we're going to use that alternative form. So I'm going to write sine of A over side A is equal to sine of B over side B. The reason why I'm going to use this form of it is because I don't know angle B, I know side B. And I'd rather my unknown be in the numerator than the denominator. It'll save you one line when you're actually solving the problem. So if I plug in my 3 givens to this, I will get the sine 42 degrees is over 22 is equal to the sine of B over 12. To solve this for B, there are 2 steps. I need to get rid of the 12. I need to get rid of the sine. How do I get rid of the 12? Multiply. So the sine of B is 12 times sine 42 degrees over 22. All right, for 3.5 space bucks, don't answer out loud, okay? Just in your head, for 3.5 space bucks, how do I get rid of sine? What do I have to do? If you said, take the inverse, you get 3.5 space bucks. There you go. There you go. If you didn't, when I throw it to you, don't catch it. Okay, but there you go. You can, oh, remote people, space bucks. There you go. Enjoy. I didn't throw space bucks at my remote people for first hour. Uh-oh, I'm probably in trouble there. They're probably going to send a letter to Mr. Kathy. Mr. Lake is giving space bucks out only to his in-person people. Riot. Okay, if we take the sine inverse, type that into the calculator, what you will get is 21.406 degrees. Okay, here's the part. This is the new thing. If you were going to pay attention for 30 seconds this hour, it is right here. We know that when you take the sine inverse of something, you don't only get one answer. You get an infinite number of answers, right? And you get 2 answers that are between 0 and 360 degrees, right? This is the answer in the first quadrant. In what other quadrant is sine positive? Sine is your y value. The y value is positive in the first and second quadrants. So this is not your only answer. This is your first answer. To get the answer in the second quadrant, what you're going to have to do is like make this little picture in your head. Right? If this is the angle in the first quadrant, 21, and that corresponding angle over here would be 21. And what would be the central angle right here from our x-axis to that terminal side? Well, it would just be 180, right? Would be all the way across minus this bit here. That will always be what you have to do. To get your second angle, you take your first angle and subtract it from 180 every single time. I know what you're thinking. Mr. Lake, do you really have to do that every single time? And the answer will shock you. Yes, every single time, that's what you have to do. And I know what you're thinking, Mr. Lake, you can't possibly have to do that every single time. Are you sure? And yes, I'm sure that's what you have to do every single time. I don't care if it's a Sunday. I don't care if you just spilled your ice cream on the ground. Always take your answer and subtract it from 180. And that will give you your other solution. but that other solution may not always work. Could our B value actually be 158 degrees? No, it couldn't. Because if you add A and B together, right, 42 plus 158 that's more than 180. So this actually cannot happen for this triangle and this triangle only, because it turns out that this, again, you notice we didn't actually ever use it, but it turns out that this is the case where A is greater than B, which means there's only one solution. Yes, I suppose. All right, so now that we know this is actually the only solution for B, we can finish out the rest of this problem really quick. To find angle C, I would subtract my other two angles from 180. And we get 116.594 degrees. To find side C, I use the law of sines. C over the sine of C is equal to A over the sine of A, which means C is equal to the sine of 116.594 times 22 over the sine of 42, just like we did for the bell work. And if you do that, you get C is 29.4 inches. And if you spot check your work, you can see that that makes sense because the largest angle, 116, is opposite the largest side. The shortest angle is opposite the shortest side, and the medium angle is opposite the medium side. But I will stress, for that, when we tested that second angle, sometimes it actually will work out. And you will have to solve for two angle C's and two side C's. And so you'll have two possible different triangles that could work. And sometimes when you try to solve for B, you will get that there is no solution. You'll get error domain when you type it into the calculator. All right, questions on this example? Does anybody need more time to write? Okay, then it's your turn. But I'm going to help you out. We're going to skip this one. We're going to go straight to this one. All right. You don't need to draw a picture. If you want to draw a picture, that's fine. But ultimately, I'm given two angles, or sorry, one angle and two sides. So how I'm going to start this problem is with the law of sines to find angle B. So first step, what is angle B? We're going to do the sine of A over A is equal to the sine of B over B. Solve that for B. I'll give you 3 minutes. It's probably more than you need. That's okay. All right. If we plug in, we should get the sine of 85 degrees over 15 is equal to the sine of b over 25. To solve this for b, I need 2 steps. First step. Roll the dice. Okay, it is you, Anna. All right, Anna, what do you got? What do I do?
Multiply the 25.
Multiply the 25. All right, and then Teresa, you would be next in line. Do you remember how do I get rid of the sine? Sine inverse. Very good. If you type that into your calculator, you should get something very strange. Anybody? Try it right now. Try it right now. I'm looking for someone from over here, from the left side of the classroom here. First person to type it in and tell me the answer will get 6 space bucks. I'll have you know that that has a currency ratio of literal pennies. Basically, how many pennies were left over from last year? You could have all of them. There actually might not be pennies right now. You might get a bouncy ball instead. Or stress ball. Ty, what'd you get? Well, that's good. You should be pressing buttons. But you got to press the right ones. George? Jackson? Oh, Caitlin? Oh, great. What do you got? It says not a number. You can't do it. No such triangle exists, buddy. Don't try to pull one over on me. And the issue here is this would be case 1. The length of A turns out to be smaller than the height of this triangle. Your B value here is so long that A cannot get back to the base at an angle of 85 degrees, which is almost vertical, right? That B value is too long, so you actually cannot make a triangle with those dimensions. Those are the nice problems. You get those, you're like, that's great. That's not too bad. Then you just write impossible a whole bunch of times. This problem is the nightmare problem. This is, I mean, fun problem. This problem is where you get to do so much math. All right, we will do the first part together because, I mean, we just did it 1,000 times. So first thing I need to do is find angle B. Okay, so I'm going to do sine of A over A equals sine of B over B, which means B is the sine inverse of 31 times sine 20.5 degrees over 12. Right? Because we're going to multiply by b and take the sine inverse. So b is 31 times sine of a over a. Calculator. You get, for your first value, b is about 64.783 degrees. To get my second b value, what do I always do? Yeah?
You do 180 minus
Subtract your answer from 180. And if you do that, you get 115.217 degrees. And if we test it this time, could B actually be that value? And it turns out the answer is a disappointing yes. I mean, a great yes, because you get to do so much more math. If you do 115 plus, or 217 plus 20.5, that is less than 180. So that actually can happen. There can be a triangle with those type of angles. So now both of these are solutions. So now what we're going to have to do is find two different possible values for C, for angle C, and two different possible values for side C, which we know how to do. That's what we've been doing all week now. To find angle C, right, we just subtract from 180. So my first angle C could be about, I think I just messed up. Did I just mess up? Is that possible? No, I didn't. I should have known it wasn't possible. 94.717 degrees. And then side C, I use the law of sines. So side C will be the sine of 94.717 multiplied by B or A over sine of 20.5. Right, that's angle C, A. Are we okay with how I got that? Am I going too fast? Remember, it's C over sine of C, so we multiply by the sine of C, and we multiply that by the ratio of A over sine of A. Type that into the calculator. You get 34.149. Meters. So that's my first options for my triangle. And if I use my second angle, again, it's the same work. Second C value would be 180 minus 20.5, but now it's minus 115.217. That gives you 44.283 degrees. And then side C would be the sine of C, 44.283 degrees, multiplied by A sine divided by the sine of A. Do that. You get 23.924 meters. So basically, how you choose to lay out angle or side A will determine whether or not angle B is bigger or angle C is bigger. Right, if you look at our example, this is the example where A is between H and B. So if we lay out A here, it makes angle C bigger. If you send A over here, then it makes angle, or I guess that's wrong. Sorry, this would be angle B in this example. That makes angle B bigger. If you send A over here, that makes angle C bigger. And that's why you get two possible solutions. Okay? Okay. Where I don't think we have time to do the area stuff. But if you would like to, this could be a fun, I don't know, ACT thing. If you want to find the area of an oblique triangle where they don't give you the actual height, you can find that because again, like we used for the line of sines, the height is equal to the b sine of A. And so if you replace that in your formula, the area of any triangle then is a half of the two sides they give you times the sine of the angle in between. So like the area of this triangle could be 1/2 of B times C times the sine of A, or 1/2 of A times B times the sine of C, or 1/2 of A times C times the sine of B. And so you don't actually have to do any Pythagorean theorem stuff to find the height. There's a shortcut, you can do that. There are no homework questions over that. It's just an ACT tip. If you want to practice, there's a guided practice in the notes where you can try using that. But again, you don't need it. So the homework for this one is due tomorrow at midnight. And then tomorrow we'll start law of cosines. And we might be able to get that done in a day. That one's not as bad, I feel like, as the law of sines. Because of the ambiguous case. It's just the ambiguous case that's kind of a struggle. There are no ambiguous cases for law of cosines if you do it in the right order. The order is important. All right, last call for questions. Jackson, how are your sinuses? George, I'm sorry, but that was the deal we struck. So we'll see you in court. And then next week, or maybe Friday, probably next week, we'll start vectors. Have you all done any stuff with vectors in physics?
What did you say?
Vectors in physics?
Yeah, we've learned about it.
It's like force at an angle or whatever,
Oh, yeah,
or
that's
speed
what-
at an angle. But you all do vectors in terms of like, it's this much at this angle, rather than like an X and Y. You do an X and Y component. The next lesson, the last half of this chapter, is very physics based. But I don't know if it'll exactly match the way Mrs. Mignana teaches it. We'll see. It didn't match the way Rupp. I knew that. Rupp never taught it this way. He always kept it in terms of just a number with like a sine, cosine, or whatever, an angle.
I know we had to draw triangles at one point in physics.
Yes.
So I think it'll probably match up somewhat.
It'll match up. It just might be a different notation than what you've used in physics. But it should be very similar concept. Have a good one, everybody. See you tomorrow.